Hello again, and welcome to our lecture on labor market discrimination. So we're going to look at what's called the Becker model, and in this model we're going to suppose there are two types of workers in the labor market. We'll just call them red and yellow workers. Now consider a competitive firm that is deciding how much of these inputs to hire. We're going to assume that both workers, either red or yellow, are perfect substitutes. So because of that, we can write the production function as a function of ER plus EY. Okay, so it doesn't matter which one we hire, they are going to contribute the same to output. So the marginal product of labor for both is the same. Now, let's think about the employment decision for a colorblind firm. Okay, so a firm that doesn't care whether they're red or yellow. And if that's the case, the market, and let's suppose that the market determined yellow wage is less than the red wage. Okay, if that's the case, then a firm that doesn't care about the color of the workers will not discriminate and hire only yellow workers because they're both equally productive. Why not hire the one that is the cheapest? And so they would hire EY workers. They would set the wage of yellow workers equal to the value of the marginal product and hire EY for yellow. Because both workers are equally productive, any differences that arise in the economic status of the two groups can certainly not be attributed to skill differences, but must be from the discriminatory behavior of market participants. The colorblind firm faces constant input prices of WR and WY for red and yellow workers respectively. And because both workers have the same value of marginal product, a non-discriminatory firm will hire whichever group is cheaper. Okay, and that's, as I said in the previous diagram, they'll hire the yellow workers up to the value of their marginal product of labor. And you can probably already see where this is going. The colorblind firm is probably going to make more profit than the other firm because the other firm is being irrational because both workers have the same productivity. Okay, so the employer that's discriminatory acts as if the yellow wage is not really WY, but instead equal to WY times what's called the discrimination coefficient, which is 1 plus D. And actually, sorry, D is the discrimination coefficient. So they're, acting as if the wage they're paying is the actual wage times some amount. The employer's hiring decision, therefore, is not based on a comparison of WR and WY, but a comparison of WR and WY times 1 plus D. Okay? And so the employer will hire whichever input has a lower utility adjusted price. We're talking about this thing being related to utility. So for an employer that discriminates, the decision rule will be as follows. Hire only yellow workers if this is less than the wage of the red workers. So this is the utility adjusted wage. And hire only red workers if the utility adjusted wage of yellow workers is greater than the wage of red workers. And so this highlights the fact that a key aspect of the Becker model, which is that if they're perfect substitutes, firms will have a segregated labor force. It's either going to be one or the other. If the wage R is equal to this, then they're going to hire the workers that they're not discriminating against. Okay, so we'll end up with a segregated workforce. So let's see let's look into a little more detail here. So we have two firms. Okay, so what's going to happen is if the wage for red workers is less than the utility adjusted wage of the other workers, you're going to end up with a red firm. So firms that discriminate will either end up being a red firm or a yellow firm. Okay? It depends on their discrimination coefficient. So a red firm will hire red workers up to the point where the red wage equals the value of the marginal product. Okay, so that's the diagram on the left. Now, if this utility adjusted wage is less than the red wage, then they're just going to hire yellow workers. And how much yellow workers they'll hire depends on the discrimination coefficient. So a yellow firm hires yellow workers up to the point where the utility adjusted yellow wage equals the value of the marginal product. And firms that discriminate hire fewer workers than firms that do not discriminate. Okay, so one of the bottom line is that in either case, as long as there's a positive discrimination coefficient, the amount of employment is going to be less than it otherwise would be. So let's look at the profits. So if the discrimination coefficient is 0, that's where you would get the maximum profit. And I mean, that makes a lot of sense. The workers are equally productive. So if you're paying more for workers that are, equally productive as other workers because you care about the color, then you're going to end up with lower profits. So if the discrimination coefficient is low, we will get that the discriminating firm will hire yellow workers because still the difference is between the two. The wage of the red workers is going to be greater than the utility adjusted wages of the yellow workers. So they're going to hire yellow workers, but there's a certain point where that inequality would change and they would only hire red workers. And so you can see the more they discriminate, their wages are going to fall, and then at a certain point, their profit is going to fall. So as the discrimination coefficient increases, the profits are going to fall, and then there's a discontinuity here where they're actually going to jump to being even lower when they decide to hire all red workers. Okay, so even a discriminatory firm that only hires yellow workers is harmed by its actions as it hires too few workers. Now let's talk about the male versus female wage gap. So women and men differ in terms of their acquired human capital. So women will tend to sometimes have lower experience levels because of, they leave the labor market to have children. They tend to have a higher turnover rate, and there's differences in household responsibilities. So, there's a difference in the turnover rate between men and women. So one way to assess the wage differentials is to do what's called a Oaxaca decomposition. Okay, so suppose we have the female and male wage ratio here, YF divided by YM. Well, we could use human capital earnings functions like we saw before. We're just going to simplify this and have no intercept. So we're going to say that ln of male wages is equal to beta m times xm, okay? And x is some type of human capital enhancing variable. For females, it's ln yf equals bf times xf. So if we take the log of this ratio, the male-female wage ratio, we will get ln ym minus ln f, and that's going to equal beta m times xm minus beta f xf, right? So if we were just to think of the male-female ratio, so if we were to divide this term here over this term, we would get this. And if we added and subtracted bf times xf, we will, and simplify, we can decompose this difference into this difference here, into these two terms. Okay, so here we are adding and subtracting bf xf to to here. So we're going to add it and subtract it. So it's not going to change anything. So we add it and subtract it, rearrange, we get this. Now this part is the return. So if females got the same return to this human capital, let's say it's education. We could assume X is education for now. So let's assume that X is education. Well, the difference in wages can be attributed to the difference in education between males and females, and we multiply that by the male coefficient. So assuming that there's no difference in the returns to education between males and females. So the difference would be attributed just to the differences in education, but then also it's going to be attributed to the difference in the coefficient times what the actual level of education of the female is. Okay, so we've deconstructed into two things. Now, this we'll call pre-market characteristics, and this we can call discrimination, because there shouldn't be any reason for a difference between the returns between males and females. Okay, so this we would call discrimination. So in a diagram, it would look like this. We have our male line and our female regression line. Okay, now the total wage gap would be here, this difference. Okay, so that would be the wage differential. And so here we're assuming that the female is going to get this much education, the male is going to get this much education, and so the female wage is this, ln of their wage is this, and the male, this is going to be the ln wage, their ln wage, and so the difference here is the percentage difference in their wage, okay, because we're using logarithms. And so part of that wage differential is due to the difference in education levels they have, so the pre-market characteristics, okay, and it's also due to discrimination. So that's the differences in the slopes times the XF, as we saw on the previous slide. So let's do some examples. So suppose we have two estimated regression equations. Ln Wm is equal to this. So here we have education, experience, marital status, and number of children, because these could be factors that influence the wage. For females, we have this equation, and so here we see that in this part of the question, we're given the averages of these variables here. So for years of education, the average is 14 for males and 15 for females. For experience, it's 10 for males and 7 for females. Here's our the marital status. We're going to say it's 50% for both. And number of children is going to be 60%. So for both males and females. So there's no difference there. Okay, so what do these coefficients imply about the differential effect of education, experience, marital status, and presence of children on the wages of males and females? So based on the coefficients and the mean values of the explanatory variables, we want to calculate the expected ln wages for both males and females. And so just to go back to that last part, since males have less education, that would be something that would make them have lower earnings than women. And here we have experience, so we have 10 years for males and 7 for females. So since males have more experience, we would expect a higher wage. And then in terms of these other two variables, since they're the same, we wouldn't expect any differences due to those. Okay, so let's calculate the expected earnings for males. Okay, so ln wage for males would be equal to 40 plus 0.7. So if you look at the equation, all we're doing is plugging in those values that we had on the previous slide for the uh, independent variables. So 14 years of schooling for men, 10 years of experience for men, and then we had 50% for being married and 60% for children. Okay. Now for women, we plug the values in. And so when we do that, we get that the lawn wage for men is 2.01 and for females it's 1.75. And now, so that difference is going to be due to not only differences in these characteristics here, so the education and experience, but also due to the differences in these coefficient estimates. Okay, so we see here that women get a lower return for work experience than men, but they tend to get a higher return to experience. We also just see a difference in the overall intercept coefficient. Okay, so what's the average total or raw ratio of female to male lawn wages? So we just, take the lawns, divide it. That's the same thing as just the actual wages. And so we get it that it's 0.87. Okay, so according to this, the raw wage gap, it says that women earn 87% of what a man does. Now calculate the expected lawn wages for an average female, assuming she was paid according to the same pay structure as the average male. Okay, if we do that, we get 190. So here we're using the coefficients for males, but then we're actually going to plug in the values for women. Remember, it was 15 for schooling and 7 for experience, and then for both it was 0.5 and 0.6. So if we do that, so if the female was getting the same returns or coefficient, estimated by these coefficients as the males, they would get 190. Okay? So calculate the expected lawn wage for the average male, assuming he was paid according to the same pay structure as average female. If we do that, the male would get 1.77. Okay? Now it says, what is the hypothetical difference in lawn wages if females were paid according to the male pay structure? Okay, so if females were, we already calculated that, remember it was 190. So if females were paid according to the same pay structure as males, they would get 190. And we know that the males get 2.01. And so this difference here is going to be 0.11. What is the hypothetical difference in lawn wages if males were paid according to the female pay structure? Well then, in that case, it would be negative 0.2. So different studies have focused on different aspects of discrimination, such as wage discrimination, sex discrimination, institutional discrimination, household, the whole number of studies have looked at a number of different aspects of discrimination. And the results, of course, aren't, they're varied. There's a large range. And we find that females tend to earn about 60 to 65% of what males earn, in part due to invisible barriers, glass ceilings in the labor market. There's indirect evidence of discrimination as reflected in unequal pay between the groups. The main question when you're looking at this is, what would women earn if they were men? And so you'd want to hold all productive characteristics constant and changing the sex only. And that would be how you would, if there is a difference, that would be attributed to discrimination. Okay, and so it occurs when, equally qualified people, men and women, are paid differently, but everything else is the same and they're performing the exact same job. So if you're, you think about the raw wage gap, and then you look for, you know, part of that can be explained by certain things like human capital differences, some demographic differences. But after you've run out of things to explain it with, if there's any difference left over, well, that must be discrimination. So a number of empirical results on gender discrimination conclude that on average the wage gap exists due to household responsibilities, family responsibilities, occupational distribution of females into lower. So women tend to be in lower paying occupations, and so there could be discrimination at the occupational level, and that's, you know, pretty much some of the main reasons. So the bottom line here, a key takeaway is that if you have any two groups of people and you have a raw wage difference, well, that wage difference can be attributed to differences in human capital characteristics. But if there's differences in the wage after you've sort of controlled for any of those things, then it's likely there could be some discrimination involved. Okay, so let's do some questions. Which element of the Oaxaca decomposition reflects the wage discrimination? Okay, I'll let you take a look, maybe pause your video. Okay, the answer is A. It's the differences in the estimated coefficients between the male and the female equations. So it's the difference in the estimated coefficients. There's no reason they should be any different. Okay, next question. So let's consider males and females, and suppose that the average earnings for males is $40,000 and $28,000 for females. The following are estimated human capital earnings functions. So we have ln male wage or male earnings is equal to 9.2 plus 0.1 SM. So this SM is the years of schooling for the males, and we're told that the average years of schooling for males is 14. For females, this is the equation. They have an average of 12 years of schooling. Now the question's asking us, what is the female and male wage ratio in logarithms? Okay, so I'll let you think about that, and then I'll let you know the answer. So you can pause your video. Okay, we're back. And so the answer here is 0.36. So you plug in the 14 into this equation and you'll get the answer. You'll get what the ln male wage is, and then if you plug in the 12, you'll get the ln female wage, and then that will be in, the wage ratio will be in logarithm. You just look at the difference. Okay, next question. So we have the same information here, but now we're asked to find what the unexplained differentials are, or the part that could be attributed to discrimination using the Oaxaca decomposition. Okay, so I'll let you think about how to calculate that, and I'll give you the answer in a moment. So pause the video and see if you can calculate the answer. Okay, so the answer is going to be 0.16, and that's obtained by looking at the difference in the coefficients and multiplying it by the female level of schooling. Okay, and this is the intercept term. So we take the difference in the intercept term, and here the difference in the coefficient on schooling. So in the lecture notes, we only looked at cases where there was no intercept. When there is an intercept, we're also going to include that, but we're not multiplying that by anything. Okay, well, thank you for listening. That concludes our lecture on labor force discrimination. The next lecture will be on unemployment, and we will see you then. Have a great day. Bye.